Hello everyone, in this video we're going to talk about the worksheet 10.1b level 2. So this is a theory about the circle, the angle in the semicircle. It's actually a special case of what we learned last time. The last time what we learned is the angle at the center towards the angle at the circumference. So if you look at this circle, so first of all we have a diameter AB, isn't it? So AB is a straight line, which means that the angle AOB is actually 180 degrees. So if you look at carefully, the angle AOB is actually watching the whole arc AB, isn't it? So do we have this angle APB is watching the arc AB as well. So now we have the angle APB, which is the angle at the center, and the angle APB, this one is going to be the angle at the circumference. So as we have the angle at the center is twice angle at the circumference, which means that the two angle APB will give you 180 degrees. So that we have the angle APB is equal to 90 degrees, which means that our APB is actually a right angle. So if you look at carefully, if we cut this circle into a half via the diameter, then we only need to concentrate about the upper half, which is a semicircle. So any angle from A and then via the semicircle to B, you will have a right angled. Okay, so that's the main theory about this. So I write it again. So angle in semicircle means if we have the AB is a diameter, then we have the angle APB is 90 degrees. So first of all, we have a diameter, then we have the 90 degrees. So what's the next theory is talking about? So it's actually the converse of it. So you reverse the condition and the result, we can say that if the angle APB is 90 degrees, then the AB is the diameter. So it looks like very similar, but actually for the first one, the angle in the semicircle, what we have is, first of all, we got a diameter. We actually got a diameter, then we can say that the angle is 90 degrees. But for the converse of it, we first of all got the 90 degrees already, then we can say back the AB is a diameter. So that's the main difference. So you need to define which one comes first. So, okay, so we mainly use for the second one, the first one in your real exam. We seldomly use the second, but you still need to understand what's the meaning for that. Okay, so let's look for the question 1. So in question 1, we have a BC as our diameter, and to find out what is X. So if you look at carefully about this picture, we have BOC as a diameter. So when we have a diameter, so that we can find out a right angle, isn't it? The right angle should be on the semicircle. So now we have the angle BAC is the angle at the semicircle. So we can say that the angle BAC is going to be equal to 90 degrees. So we have angle BAC equal to 90 degrees. As we look at carefully for the triangle BAC, the angle sum of triangle is always be 180 degrees. So that we have 2x plus 3x plus the 90 degrees will give you 180 degrees. If you solve it, we got 5x equal to 90 degrees. Then x is going to give you 18 degrees. So that's for question 1. So now we're going to do question 2. We got AB as our diameter. AB is the diameter, and we have DE is parallel to AB. So DE parallel to AB means that we have two right angle here, so DEA and together with the DEB. So this two angle is going to be our right angle. So the question is asking about to find the angle ADE. So we locate it first. Angle ADE, so ADE. So what we're going to find is this angle. So that's the angle we want to find. So let's think about it. If we want to find out this angle, that's what we want. We have this right angle. If you want to use the angle sum of triangle, which means that you have to understand, you have to know that what's this angle here, what is the angle A. So if you look at the large triangle, look at the triangle ACB. If you want to find out the angle A, we got the angle B is 48 degrees, which means I'm going to find out angle C. So angle C is actually the angle in the semicircle, isn't it? And we have the AB as our diameter, so that angle ACB is actually a diameter. So that's how we do these questions. So first of all, we can say that the angle ACB is a diameter. So we say that angle BCD is equal to 90 degrees, and the reason is angle in the semicircle. So now we got the angle A, angle C is equal to 90 degrees. So after that, we look at the triangle ABC. We know that the right angle, we know the 48 degrees, which means that if we consider about, sorry, where is it? So if we consider about the triangle ABC, in this triangle ABC, we have the angle A plus 48 plus 90 degrees. 90 degrees will give you 180 degrees. So the reason is the angle sum of triangle. Then we can say that this is 48 degrees. So that the angle A is going to be equal to 90 degrees minus 48 degrees give you 42 degrees. So that is for the angle A, this gives you 48 degrees. So now we look at the smaller triangle. We got the 90 degrees here, we got 48, so we can use the angle sum of triangle again to get the value of the required angle ADE. So now we consider triangle ADE. Consider the triangle ADE, then we have the angle DAE plus the angle ADE plus the 90 degrees is going to be give you 180. So because our angle A is 42 degrees, so we substitute in to find out the angle ADE is equal to 90 minus 42 give you 48 degrees. So that's for question 2. Now we can look to question 3. So for question 3, we have AOBC is a straight line. So AOBC is a straight line, and A, which means that the AB, because it's passed through the center, then it's going to be the diameter. So now we have the AD is equal to CD, and we have the ABD is equal to 62 degrees. So now what we're going to find is to find out the angle of ADB. So this is ADB. So if you look at carefully, ADB is actually the triangle in a semicircle. So actually we're using the angle in the semicircle. So now we have the ADB is actually 90 degrees. So you can just say that the angle ADB is equal to 90 degrees due to the angle in semicircle. So in the next part, we're going to find BCD and BDC. So where is BCD? So BCD is actually here. So that's the first angle we need to find. We got this angle is equal to 90, and we need to find out what is the angle of BDC. So this is two angles we need to find it out. So how can we find it? So first of all, if we have these two lines are parallel, which means that this angle is going to be equal to this angle, right? So that's the something we want to find. So we let it as an x. So now if you want to find out x, you look at the triangle ADB. You have the angle D, you have the angle B, then you got the x. So now you got x, which means that you got the angle BCD. Okay. So now we just need to find out what is the angle here. This is something we want. So if you look at carefully, you look at the triangle BCD. Then we got an angle BCD. What we want is this one. There's a relationship if we write it like this. This angle plus this angle gonna be our exterior angle, isn't it? So that we can just write something down. So now we can say that as AO, as the AD equal to DC, so that we have the triangle ADC is an isosceles triangle. And now we have the angle. Now we have the angle DCB. DCB is this one, which is going to be equal to the angle DAB. And the reason for that is the base angles isosceles triangle. So now we know these two angles are the same. So how to find out this angle? If we consider about the triangle ADB, then we have the 90, have the 60, so we now got the angle A. So we consider the triangle ADB, so that we have the angle A, which is equal to 180 minus 90 minus 62 degrees. For the reason is the angle sum of triangle, this one will give you the answer should be equal to 22 degrees. So now I have this is equal to 28 degrees as the base angle. The angle C is equal to 28 as well. So now we have our angle BCD is equal to 28 degrees. So now if we consider about the exterior angle, if we look at this one, then we can say this is the unknown, this is 28, so we have this is the plus together will give you 62. So we have the angle BCD plus angle BDC is going to be equal to 62 degrees. The reason for that is the exterior angle. Then we can say the angle BDC is going to be equal to 62 minus 28 give you 34 degrees. So that's for question 3. Alright, question 4, we have the AC is a diameter. AC is the diameter. AC and BD intersect at E. So first of all, we got the angle BAE is equal to 43 degrees. The question is asking you to find out the angle ACB. So this is ACB. So first of all, as the AC is the diameter, which means that any angle on the circumference or on the semicircle is going to be 90 degrees. So first of all, we can just say that the angle of ABC is equal to 90 degrees. For the reason is the angle in a semicircle. So then we can say the angle ACB plus the 90 degrees plus the 43 degrees, which is the hair, and hair. So if these three angles plus together will give you 180 degrees, which means that the angle ACB is going to be 90 minus 43 give you 47 degrees. So in part B, we have the AB now is parallel to DC. So first of all, locate it first. AD is parallel to DC, which means that if this is 43, we have a Z-like things, right? So it will have a turning angle, which means that this is going to be 43 degrees as well. So now we have the angle BAE is equal to the angle ECD is going to be equal to 43 degrees. The reason for that is the turning angles, and we have the AB is parallel to DC. So now we can say that the angle of BAE is equal to 43. So now we need to check is that BD is the diameter here. So if we want the DE or DB to be the diameter, which means that these two angles plus together should be equal to 90 degrees. So if that is 90, then it's going to be correct. But how can you do it? How can you find out this angle? So actually, what we have found is the angle ACB. So, or angle ACB. Angle ACB. We haven't find angle. We have find out the angle ACB is equal to 47. So we can locate this is equal to 47 degrees, isn't it? We find it in part 1 that the angle ACB is equal to 47 degrees. So now we have the angle DCB is equal to 43 plus 47 give you 90 degrees. So that we have the DB is the diameter. What's the reason for this? Is the converse of angle in semicircle. Okay, so that's for question 4. So now look to question 5. This is extremely easy in these questions. They said the distance between AC and 3 cm. So first of all, we link them together. We link the A and C, and now we can see here, this is actually a half circle, isn't it? That's the semicircle, and we have an angle at the circumference. 30 plus 60 give you 90. So first of all, we can write the angle ABC is equal to 30 plus 60 which give you 90 degrees. So now we have this is 90 degrees, which means that the AC is the AC is gonna be the diameter. And you got the degree first, then you gave me the diameter, which means that it's the converse of the angle and semicircle. So now we find out the AC's diameter. So the circumference can be calculated by pi times the diameter, which means that pi times 3, which will give you 3c. Okay, so for the last question 6, we want to find out all of the right angles. So first of all, if you see these 3 numbers, it's actually triples. So we can use the Pythagoras directly. We check the 6 squared plus 8 squared is equal to 100, which is equal to 10 squared. So now we can say that the angle of BAD is going to be equal to 90 degrees. It's not Pythagoras theorem. Pythagoras theorem means that if we have a 90 degrees, then we can say a squared plus b squared equals c squared. But now it's the converse of it, because first of all, we got a squared plus b squared equals c squared. Then we have the angle ABC is equal to 90 degrees. So this is actually using the converse of the Pythagoras theorem. Okay, so now we got this is the first right angle. And as now we have that is equal to 90 degrees. This is equal to 90 degrees, so that we have the BD is what's that called? Is the diameter. So now we have the BC is the diameter, so that the angle at the center is choice angle. The circumference, where we can just use the angle in the semicircle. So now we have a diameter, so that we have the angle BCD is equal to 90 degrees as well. So the reason for the first one is the converse of angles in the semicircle. And for the second one is actually the basic one, the angles in the semicircles. So that's how you do the all exam, all questions in this worksheet, the 10.1b level 2. If you have any question, don't hesitate to ask me.